on this example, I want to show you how to solve for the steady state without just raising it to a large power. So what we do is we have to solve well, when it goes to a steady state, it means whatever that steady state is, when you multiply the transition matrix times the steady state, you just get the steady state back. So we're really solving for this, we're solving this equation for x. So let's look at that. I'm gonna write it like this: px equals x. And so our p in this case is 0.9, 0.8, 0.1, 0.2. And I don't know what x is. I'm just going to call it xy. So we've got to solve this system. And this is a little weird because we've got variables on both sides. We've got them here and here. So what I'm going to do is write this out as a couple of equations. It gives us 0.9 x plus 0.8 y equals x. It also gives us 0.1 x plus 0.2 y equals y. All right. So what I think, before I do anything else, let's get rid of these decimals. I'm going to multiply both of them by 10. Move this over here. So multiply this by 10, you get 9x plus 8y equals 10x. You get x plus 2y equals 10y. And now I'm going to combine my like terms. So this top one, I'll take the 10x off of both sides and get minus x plus 8y equals 0. And the second one, I take 10y off of both sides, I get x minus 8y equals 0. It looks like we're in trouble here because we're trying to solve this system for x and y. And these two equations, you can look at them and tell, these are both the same line. So do we have anything else that relates x and y? Well, yes, we do. Remember, x and y are the proportions of people that are in one state or the other. We also have to use the fact that x plus y is equal to 1. So what we've got here is a third equation, x plus y equals 1. So we could take these, I'm just going to take these two here and solve those. If I do the top minus bottom, I get x minus x is 0, negative 8y minus y is negative 9y, and 0 minus 1 is negative 1. So I get y is 1/9, and x, if x plus y is equal to 1, x has got to be 8/9. So that, well, if we write that as the steady state vector, steady state vector is going to be x on top, y on bottom. And so that's how you do this if you wanted to do it by hand and not use a computer for it. This is sort of a, what's the word? It kind of foreshadows one of the concepts we're going to do later in the semester called eigenvalues. Because if you think about it, this steady state value, steady state vector, it's the solution to px equals x. And so it's the unique, or well, maybe I shouldn't say unique, but it's a vector that you multiply this matrix by, and the matrix has really no effect on it. And eigenvectors are like that, although sometimes they might change the length, but not the direction of the vector. But anyway, that's this whole process that we went through up here that involves subtracting the x and y. Notice we subtracted 10 off of here and then 10 off of here to get this. That's going to come back later in the semester.